Stream time. Surprise. Should I be sharing this elsewhere? Let's see. Maybe put it on Twitter. Wait for YouTube to kind of catch up. Oh, I'm gonna leave that one off. Cover that. Fix that window. Let the analytics catch up. OBS says it's fine, which is good. Put that on Twitter. Should move that window back down here. Do I? Maybe I'll move it up to that one. Oh, the joys of having multiple monitors. I thought I turned that light on. Yeah, it's on. Oh, it just turned itself off. That's weird. Oh, did something break in Code? I think something broke in Node-RED. Ooh, something did break in Node-RED. Well, there's a touch panel that's broke. No, touch panel says it's on. Oh, weird. Something broke with one of my automations. Interesting. Oh, don't really need that light on anyways. Yeah, that's a weird one. Does this one work? Does the other ones are working? No, that one turns itself off too. Weird. Something broke. But it's weird that it recognizes the other ones are on. Interesting. I'll have to track that one down. Although probably not until I get the server up and running and just switch everything over anyways. Right. New project. Involves circuit boards. And I made the silly mistake a while back of accidentally deleting my hard drive. Thankfully it was only the OS hard drive. But I did lose my KiCad libraries. So I have to rebuild those. And it looks like we're also on KiCad 9. So let's download the new KiCad. Okay. Just download KiCad 9. add things to my to-do list. Keycat should be downloaded. So let's get that installer running. If it does something. Oop, there we go. Okay. That's installing relatively quickly, which is nice. I have a variety of components that I already know I need for a project. I was making notes the other day. Where are they? Is it a question? Where did I put them? In the notebook, in the notebook. Got the notebook. I'm just gotta figure out which page I wrote it on. It's back. Pages. I don't think it was that far back. I'm pretty sure this is the right notebook. Okay. Yeah, there it is. I'm gonna need 2 projects. Ooh, we've finished our install. Import from previous settings. We got KiCad 9. So let's switch our view. We have KiCad 9 loaded, which mostly just looks the same, and it's open in my other window at the moment. Its main thing, just this. I need to make project files for it. Let's make 2 files. One is a TMX driver, and the other motion gloves. And for both of those, to make it easier, let's find a DMX not a DMX, let's find a KiCad folder to copy over. Projects. Folder 5000. day. Go to, what's this project? Mushrooms. Copy that folder. Sorry, not showing the file structure of my computer. I don't want to accidentally show a project I shouldn't. Okay. Now that those open, file, open project, projects. Let's start with the DMX driver because it's the easiest project to start on. Open schematic view. First time using a new schematic library table. Yeah, okay. And I already see the first thing that needs to change, and that is preferences. Yeah, no. How do we change it? Plugin manager. Let's try that. An active bomb I want. That one. That one. Let's see. theme. Apply pending changes. Let those download. Okay, that was faster than I expected to. Preferences. Close. Change to that. Editor. Footprint editor. Colors. PCB editor. Colors. Haha, there we are. That's what we like to see. Now, this stuff I don't, well, I like keeping that label, but this label I don't need. This device is not going to need Ethernet. We're not using KNX, but we are using the opto isolators. We are going to keep quick connect on it. We are going to remove this 6-pin connector. Don't need that. That one. Actually, we'll keep both. But we're going to merge that. Let's keep that over there for now. We're gonna keep USB programming as well as we're actually gonna add a second USB for HID mode, and then there also needs to be power for everything. Through USB without backfeeding. So there'll be more than one power input. We're not going to use a terminal block on this design. I'm actually going to use a barrel jack. So we do want 3.3 volts. As well as a 5-volt isolated supply, so that can stay. Should only need the 4 mounting holes. The fun part is I have to rebuild a lot of these items, as my libraries no longer exist. So that's an item that has to be rebuilt. But let's move this over. There's actually going to be one extra isolator here. I should see what the stock levels are like. USB. They do have it in stock. Good news. That is good. I like things that are in stock. There'll be an extra chip that has to go in on that. Actually, this is no. This is the 3.3 volt version of this chip. So almost this exact chip needs to be used. So let's copy that over to here. These two are going to work together, but that needs to be a different chip. So let's see if I'm lucky. And if that max chip is available. Built into KiCad. They actually do use that one. SpokeFun has a similar product that does isolated DMX. Max. What's the main chip that's used? There's a different chip number. Interoperable with 5-volt logic. I'm looking at the datasheet right now for this max chip, because I thought this was this is typically what you use if you want 3.3 volts for your logic, but because it has the isolation, it would be running on 5 volts because DMX is 5 volts. I'm just wondering. 5 running at half duplex. Supply voltage up to 7 volts. Interesting. Neat. And it's rated up to 12, which I think Keith, first one here, or at least first one in the chat. Um, so this might actually be rated for what I want. Minus 485 is the standard one. The goal today, ideally, because obviously John streams in a little while, is to try and get most of my schematic done. I'll have to. I can copy a lot of symbols from old projects, but I'll have to rebuild libraries at some point because many months back I accidentally deleted my hard drive, which had my KiCad libraries in it. So those have to be rebuilt, but thankfully all the obviously I can grab symbols from old projects, and the 3D files were kept on a different drive, so it's not too bad to rebuild them, but obviously have to rebuild them. But I've given myself a new project because we all know that we should add more projects to the to-do list. I've signed up to potentially do a presentation in June. And I decided I wanted to add some extra elements of interactivity to this presentation, which isn't guaranteed because I have to wait to hear back from the committee running it. And that interactive element I'm thinking is to build some like motion gloves. So the gloves and the fingers would have flex sensors, and then the electronics would have an accelerometer, the battery, there would be a vibration motor, some LEDs for feedback, and then it's based around the ESP, so it'd be Wi-Fi, and the idea being I can program different motions to control things throughout my presentation. Combine that with some DJ lights that I have, which run on DMX, so I can interact with the lights or control the lights with my hands. So I have a few static lights, I have motion lights so they can move around, and I'll find ways to interact with it throughout the presentation. Plus I have this DMX board that I'm designing. I'll use it because I'm going to use the ESP S3. I'm going to set it up so that it can also control a light itself, because I'm going to use one of my tower lights that I've built in the presentation. So I'll hook that up to something, and then the other one I want to do is I'm going to add an extra USB port so that one of these boards can act as an HID input device. So the gloves will also be capable of controlling my PowerPoint presentation. So everything will kind of be able to tie into itself. So essentially two boards, but the DMX board has the most cross-compatibility with what I want to do. And I've given myself a relatively short window to work on it. I do indeed like to challenge myself. The presentation is on, would be about my experience, because I'm getting into the field of child and youth care work. So it's talking about my experiences and what's led me to the career that I have, but also talking about my experiences around technology and how I use technology and how I want to use technology. So I figure this extra element of interactivity would bode well for a presentation about technology and how it can be utilized. Under seat speakers. Not a bad idea, but I don't need to add too much to the to-do list. I'm gonna be right back. I have to do something. Okay, I'm back. Apologies. And hello, Johnny. Thanks for joining. And yes, I think it'll be fun having a new project. The trick is, can I turn it around fast enough that I can actually use it the way I want to? Well, if the example schematic I have is correct, then I should be capable of using this one-to-one, which is good. Won't need that connector. And I'll have to put jumpers on this, as you likely won't actually need that. The LEDs are good for debugging, so we'll leave those in place. And can do. Where's this schematic? Let's figure out what order this needs to be connected in. So this is T. There's a different isolation chip used, so I have to understand how it works. 6 and 7. 1. Yeah. So trying to set up isolated DMX, and thankfully SparkFun has this lovely LED driver board that would almost meet my needs as a way to follow. So now they have extra resistors in place here. Ooh. And they're much higher too. I'll have to change that. If they think it needs to be 680 ohms. Wow. It's quite the pull-up. The big thing here is understanding these isolators in regards to the isolators I have. They're using a single channel. Let's see here. Split this up, single channel. So pin 2 and 3. So that's an incoming transmission. It's going to the LED. Whereas, okay, so would be that side of this device. So if I'm transmitting out of my MCU, so transmitting out, which is transmitting to the so it's this line here is that first one. So let's make this a little easier to read. Go there. Let's isolate these. one extra one. That is for the enable. But that's for transmitting out. So we're gonna match these two files. So that'll go up here, and then we'll have this one here. Now this one, I want it the same way as this one down here. So rotate. Just copy this. Make it a little easier on myself. Resistor to pull up on that line. It looks like it wants pull-ups on those lines, yeah. I think I did that backwards. It should. And that's to 3.3 volts. So that gives me enable. And let's add a note. Text. This will go somewhere here. Volts. Leave those there for now, but they do have to be changed. These. I think that's everything. I'm just going to move the schematic to my second screen. And we need a different ground here. So. And I'm gonna need one for 5 volts. And connect from here to there. Gives us 5 volts, and that gives us 5 volts. Volts, ground. There, and 5 volts over here. So we're receiving on DMX, going to our ESP, we are transmitting on DMX, and then I just need the DMX connectors. Do we have XLR plugs? Ooh, we do. Cool. So I need 2 of them. And pin 1. Pin 1 is ground. And pin 2 is B. And then pin 3 would be pin A. Yeah. So those are your DMX connections. There's a lot of components for DMX. My goodness. You can simplify with a lot of the LED indicators, but that's fine. ESP is gonna need changing. USB-C, HID. And open another project. That has a good example. There's a few projects I need to open. Let's see, let's open let's double check this project first. I think it has a good that stuff's fine. This is what I want. It's got USB information. And I realize my first error, which is the 5 volts up here needs to be its own isolated 5 volts. Could make this V bus. It's potentially a problem, depending on which isolation transformer I use. Because if it's not a direct DC to DC, then this 5 volt I put won't latch. Although I don't plan on running DMX from USB. It'll just be programming. So, I think I can get away with it. Let's change that symbol. So, we can copy this to here. I do want the USB attached to ground. We want a V-bus to be connected. They're gonna have diodes on them, so there's no backfeeding. That's pretty. And then I'll need the connections to the ESP. Don't need those ones. Those diodes. I think it's the SM007 that I want. thought I had a window open. Yeah, yeah. SM007. 007. No. Ah, 407. It looks like the right one. Maybe it's not. I'm trying to think what project uses it. I'm gonna have a project that uses it. Trying to think what project would have used it. Actually, I think I know which one would have it. Let's try looking at this one. Yeah, here we go. This is the diode I want. And this needs to be to ground. Do not place flag. And alright, I need to add that to here. And now gives us 5-volt input when USB is plugged in. You know what? For the sake of doing so, let's add LEDs to that. But let's use a 10K resistor on that. That way I can see where the power path is coming from. That also leads to... I need a power jack. I think keycap has a good one built in. 2.1 millimeter. Ooh, DC barrel jack. DC barrel jack. This is what we need. And also gonna need my large size diode because I will be tapping into power from this. So to C is pretty much set. Power supply. So with this we can have does it? So I could just directly tap this to the lights. In which case I'd only need the small fuse, which saves me on pick and place fees. Let's do that. I believe it's center positive. Yeah, center positive. Which gives us let's go in here. Looking for VCC. And do it here too. All of that BCC comes together to form the input of the power supply on 3.3 volts. We will add open a project with LED controllers. Grab MOSFET packages and grab terminal blocks. Now with the terminal block, I know one of these is gonna need power. And I might as well make it a 6-channel capable device. So I'll have an extra pin on the terminal block. And we can add in an extra MOSFET. Make sure it's using the correct power symbols. Switch this to channel 6 and FET 6. And they'll all need 10K pull downs. Getting too close to the edge of my screen there. Let's move them over here. Here's the MOSFETs. We have power for external lights that I can control from DMX. This board's gonna act as like a 3-in-1, so I can use it as an HID input device over Wi-Fi, which is one of my intended uses. Hence the dual USB ports. I also find it easier to program an ESP through a serial chip, even though it has USB-C, well, not USB-C, but just general USB programming capabilities. I just find it a pain in the butt, and I don't want to figure out what it's going to be like trying to not only program, but then use HID mode on the same port. So instead, I'll use 2 different ports. and USB-C because USB-C is superior. During programming with USB or even using HID mode, I will not be using DMX. So the diodes will power directly to this, and I can add in this VDD power path on the other side of the barrel jack, and this input will be running 12 volts to external lights. So in one of my instances, I will be hooking up one of my light towers that I have that I use for stuff. So I'll hook up one of those to it. So over Wi-Fi, I can tell my device what to do, but it's also going to provide a jack spot for DMX, and the DMX will go to a DMX light. So over Wi-Fi, I have both direct control to my plugged-in lights to this circuit board, plus Wi-Fi based DMX control, which shall be fun. What I like about it in my head is that, for the most part, the functions should be straightforward enough that programming will be relatively simple, because it'll be based on me sending commands, and the commands can be done in JSON and through Node-RED. So the programming of these specific control boards should be a little simpler. Whether or not that actually happens, we will find out once these get made. And for the most part, these boards are using known schematics and known components. That is nothing, unless I make an egregious mistake, they should just work. The other thing I need to do is swap out the ESP. Let's find a project that uses an S3. Should have what I need. ESP32S3 would be the one. Hello, intermittent tech. I think a few people are still here. They're just being quiet in the chat. Hey, some call it fun. Don't need those. Not that. Not that. Accidentally hit the home button. Over here. That. Don't think this project is going to have an addressable LED on it. And don't currently have plans to put anything there. should see if GLC actually has this. Oh, I have the part number. That's a starting point. Be nice if they have this. They do have them in stock. Not bad. $8 a piece though. Oh my goodness gracious. Oh, pardon me. Oh, couldn't get to the mute button fast enough for that one. $8. What's the price point on mouse? I bought these not too long ago. Curious what the price difference is. Yeah, oh crap. It's just under $6. So let's pull out the calculator because I like being precise. We have 59, 50. So subtract 5. Paying an extra $1.65 for it, which is weird to me because, like, yes, Mouser buys these things a dime a dozen, but LCSC is in China, and so is Expressive. So you think they'd be getting a better price point on something like this. Yeah, even LCSC has this for a better price. That is so weird. Oh, sorry. LCSC is set to US currency, and it doesn't let me change to Canadian, so let's switch back. Yeah, okay, so it's slightly cheaper from GLC, but still more expensive. Yeah, so weird to me. Of course, they do everything in US dollar. Fun times. But it's still cheaper going to Mouser to get the down circuit board. Or not the circuit board, the ESP. Which is so weird to me. But I don't feel like hand soldering, and there's so many parts on this. But I also don't want to sit here ordering everything and placing it all and doing all that stuff, so I'm planning on having everything pre-assembled. So, price is gonna be the price. It is what it is. That's what I get for coming up with last minute project ideas that I want to fast track. Right. Oh, everyone's favorite fun task. Which pen goes to which item? Oh, I hate doing this. I need to find myself a reference schematic. I don't think I've used an S3 with USB before. In my own designs, I mean. Trying to think. Is there a design I've used it on? Okay, I found one. On CH340, pin 2 is TX, goes to RX. Now, for USB HID, we want not text. I want a flag. IO19 is USB. D minus. And then IO20 is D plus. Okay. So that connects those. And that leaves I2C for quick. That's that one done. Wonder if John's gonna notice before his stream. Or has he already been lurking, just being quiet in the chat? I know I'm gonna need buttons. 2, 3, 4, 5 buttons, ideally. If I do, it's kind of like a button pad input. I'm gonna use an I2C OLED display, likely, on these. We have what am I missing? Oh right, I need to add controls for all the MOSFETs. So we got 5 MOSFETs, 5 buttons. We have 10 I/O lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Yeah. 25, 26. Yeah, got enough I/O lines. Okay. Open up another project. Has ESP. Basically, just use whatever pins were available. Let's do it over here then. IO 41. IO 42. Weird. I keep changing which convention I want to use. Should really pick a convention. I got like the IO number first, to be honest. I'm gonna leave those as is. These ones. Can go. No spots. That leaves. Turn the IO for enable. So let's do it on IO 40. That's that one. That leaves buttons. I want pull-ups for the buttons. And let's find a 10K resistor. that one down. What's that? Ground. Ba-ba-da-da-da-da. Think that gives me all of the functions I need. Right. Still need to finish the power supply. But I can start moving things into place. With let's start from the bottom. The MOSFET type. In my case, the light I want to control is controllable on the ground side, so N-channel MOSFETs. I've used these particular MOSFETs before for lighting control. It's actually running the lights in my room right now. These particular ones are absolutely overkill for the light that I want to control, but if I ever want to control a different light, they'll be very handy, because they're running... I wonder what the longest strip is in this room. I think the longest one is under the desk. No, there's about a 5-10 meter spool under the bed. That's the longest one that it probably runs. These particular ones are rated for like 10 amps. 10 or 8 amps? Something ridiculous. For SOIC 8. So, decent sized chip, but pretty good. The other one I would use is probably an AO3400. Those ones are fairly good. It would work in this application. But again, if I decide to use something different down the line, I don't want to have to do a PCB upsize. Just do it the first time, overkill, and I don't have to really worry about it. So yeah. For this, it's just familiarity and knowing that it will meet my current specs and likely the future specs of anything I'm going to need this particular board for. These, you'll sooner burn up the barrel jack than you would blow up the MOSFETs trying to drive an LED. Which is why, unlike the LED controllers, I have these pin blocks, and I normally reserve an extra set of pins simply for power input. Oh yeah, I think my tower light, actually, I can tell you exactly. The desk somewhere. Let me look. Got him here somewhere. No, not there. Let's see. Yeah. I know I saw them recently, because I've been moving things around. This one? Nope. No, I have them here. Oh, that one. Glad to use them for testing. I know they're here. Not those ones. Hey, this I was finding. Oh, goodness gracious. No? Not there. Where in the world is it? Goodness gracious. Probably is. Oh, they don't even get hot under a full like 5 meter, 10 meter LED strip. Which, granted, depending on what you're running, which I've got, what do you call it? I have a mixture of RGB CCT and CCT LED strips. I think the full CCT strip can push a good amount of power. And even those I haven't had much issues with in terms of getting hot, and they're easily pushing near the 3 to 4 amp range at full brightness, that is, which rarely am ever at full brightness. Just haven't had the need for it. Found some of the circuit boards that I have. Let's switch the camera view. So these boards, they're in a panel, but they snap apart. And I have a few of them made up. And the panel is set so that it's like a panel of 5, but I think there's more than one section to it. I don't think I just did them as a strip, although I might have, because the tower light they're in is a 5-bay light, so it's red, yellow, green, blue, and white. So each segment has 6 LEDs, 3 series, 2 parallel, so that 12 volts goes in and it lights it up. These are ridiculously bright, even with the epoxy tinted lenses that are on there, and then the whole thing is like 3D printed. It actually works really well, and that's what I'm going to use one of these boards for in a demonstration. But this is an example of one of the LED drivers that I have. So this was the first iteration of this one, and then I moved to just having the ESP directly on board, and the file's on GitHub, and you can just order it ready to go. So this one, you can use the barrel jack to power it and run a small LED strip, but there's extra slots on the terminal block, which is rated for 10 amps, so that you can really push it, but the MOSFETs are all right there, and these ones work quite well, but these I think are really low powered. Oh yeah, let's power up the bench supply and see what these push. Turn that on. Jeez, that's bright. So that's almost 1.5, well, just over 1.5 watts at 130 milliamps for blue. I think they're all kind of spec'd that way. That's, my god, that's so bright, and that's at less than a watt, exactly a watt there. Which color is this one? Is this one backwards? I think one of the LEDs is backwards. Yeah. I don't know why the manufacturer screwed up on that one. So that's another 130 milliamp one. And I can only imagine what the white is. God, that's bright. Yeah, that's 124. That is ridiculously bright to look at. But yeah, they push a good amount of power. Well, not a lot. So like for their brightness. this MOSFET will be more than capable of handling it during a presentation. I wonder if Fusion has that project file still. Oh, good. Come on. Oh, mine are not getting anywhere near that. I feel 0 warmth. The exact parts I use, let me just double check. Because I think I've used one more than the other. Used that one. And I've used this one. So that one's 22 milliohms at 4.5 volts. So yeah, the second part number is the one that I use more often, which is this one. That's the one I use most often. I think most of the time I'm around the 5,000, whatever level ESP programming it sets it at for that. I think it's hertz. I don't think it's 5,000. So that'd be 5 kilohertz, I think. The other board that uses it is powered through a PCA chip. It is the PCA 9685. And that one, I pretty much max out its capabilities. Driving. So it's a 12-bit resolution. I forget what its top frequency is. It's 1,526 hertz is what I normally run it at. Yeah. Yeah. I should test what its resistance is one of these days. But I know it's not getting hot. Like, I mean, like, I've put a full-on 5-meter LED strip on it and run amps through them and not even close to getting warm. I wonder what exact LED strip I bought. LED strip. Don't think it mentions. power levels are. This is a 50 by 50 millimeter LED, and has both RGB and white chips. Warm white, cold white chips. Pain in the butt to solder the pins on them. Oh my god. And you get a 10 millimeter strip that's got 6 lines on it. Wow. But they work really well. I digress. Let's see. It's under workshop. It's this one. Or is it this one? Yeah, here it is. This is the project for the tower light. So, because it's getting mounted on a wall, I only needed a 180 degree field of view. And most of the ones you can find online are really expensive, unless you're using a 360 degree version one. I didn't particularly want to mount a 360 degree one. So the LED circuit boards fit into it. Do I have? Don't think I have it, but what I did is I made a mold of what the lenses are supposed to be and 3D printed them. So this is what the mold was, and I go along this edge which has a chamfer on it, and I hot glue it, and then mix up epoxy resin, just cheap $5 dollar store stuff, with some cheap resin tint from Amazon, and fill the molds. I think I made enough molds to do a bunch of lenses at once, and then I think I made an adjustment because I realized the resin would sink a little. So yeah, so I realized the resin would sink a little, and I needed a way to help it actually go in this relatively small opening. So I made a new mold that made it easier to pour into. Oh. Thank you. There we go. So I made this 3D printable mold so that I could pour epoxy resin that had some tint in it to make the lenses, and then it fits. I just sand the edges after it's pulled out of the mold. A little bit of super glue, and it fits inside this 3D printable assembly. The circuit boards go onto the back there, and there's space inside for the wiring to kind of go down. I think this is the most recent version. Yeah, I think that's the most recent version. So I went through a few iterations on it. Oh yeah, so what I would do is I'd kind of pull it out when it was mostly hardened, and I would lay it into like a resting place so that I could fully cure nicely, but also so that I could just keep the resin flowing. Hello. So yeah, that's one of the items I want to power up for a presentation, and hence that's the reason for the circuit board design. But well within the specifications for the MOSFETs. Is it really your first time catching this live? Ah. Yeah. Now that I got an extra project on my to-do list, I should probably live stream a little more often. I have almost everything on this design that I need. The only things left are the power supply. Yeah, mostly just the power supply, I think. Whether or not I can case this nicely. Some rectangles. Is that annoying? Give me a little more space to move that over. Hopefully that fit. and that's in place. I'll probably put the buttons there. They really don't need to be in the format they're in. So first button, second one, third, fourth, and fifth. Let's give myself a little more space here, because I can. And then that leaves stuff fit in its normal spot down there. And then that leaves the power supply. So the part missing from this power supply is I need a DC-DC isolation transformer for DMX. I know I was looking at them for another project and I totally forget which one, because I had a part number for it. Look at the one that SparkFun did. They use RFB 505S, which is, I'm assuming, a 5 volt to 5 volt. RFB 505S. Which is Recom isolation module. Puts 5 volt 200 milliamps. Its input voltage is 5 volts. Okay, so it's similar to what I want. Yeah, do it here. I don't think. Oh, they do sell it. Ooh, that's intriguing. Okay, so if I do 12, no, we're not isolated power modules. Number of channels 1. Supply. What's this one rated to? Yeah, okay. Put voltage of 1.5 kilovolts. Okay, so that's fine. So it's output voltage. Does it say? Turn 1 watt. input voltage 5 volts. I think this is similar to what I was looking at for a different project. And if it is, then I should be able to do this for 5S. Ha. The big thing to double check with some of these is the minimum required load. Actually, does this one list the required load? It's in Chinese. Let's check this. Input efficiency, max load, single input output. Right. Shouldn't require too much. So the big thing with this. Five volts, 200 milliamps, typical efficiency, and capacitance. Right. R3. So what's the difference with R3 and R2? Right. This one has the minimum listed, which would, I'm pretty sure, disqualify it from my list. Yeah, so this one does not list a minimum maximum, unless this column is the minimum. Google Translate. Yeah, so this is the minimum column. Okay, so this is the product that I want. Note in the notebook. Where's my pen? Isolation regulator. B1205S 1WR3, and that is C229241. And if we check on GLC's webpage, they have it available, although no stock. But it is available, so which the minimum quantity is 5, yeah, okay. So it is available. Yeah. So that'll be what I want to use, and its footprint. It's got a unique footprint. Doesn't have it. Lovely. So I'll have to draw it out. So I'll have to draw out a custom part for that. That's the only thing missing from this one. I wonder if John's cutting it down to the last minute to start his setup for his stream, because normally he would have noticed by now and said hello. Actually add a 10K resistor for this. Ground one, ground one, ground one, ground one. So this whole section is its own isolated thing. For DMX, you're supposed to have isolation per DMX standard. Obviously you can get Arduino boards that don't put the isolation in, and it would simply just be this max chip in its place. But you're really supposed to have isolation. Hence adding isolation, and I chose these ones over the ones that SparkFun has in their diagram simply because I've used these ones and I know they work, and I'm more than meet the specification. And then I got note for this transformer, and add the note of the part number. B1205S1W3, and that is C2292411. Once that's added, that's all the parts necessary to make this control board work. But the idea for this project is this is one of two boards that I have to design. The other one is a board for motion gloves. So I would sew together a pair of gloves that have flex sensors in the fingers. And then the control board would have a spot for battery monitoring, charging, an ESP chip because everything's going to run on Wi-Fi, an accelerometer, a haptic feedback, an LED indicator, probably a few buttons too, and the reason I'm making them is for there's a potential presentation coming up in June that I've made a pitch for to do a presentation, and I'm holding my fingers crossed that I get selected. And I already had thoughts of, obviously I already know what I want to talk about because I had to make the pitch for them to accept it. But I was thinking of extra things that I can put into the presentation, and I thought it'd be really cool, rather than sitting there with a PowerPoint clicker, to have the gloves actually do it for me. So the board schematic that's currently on the screen has an extra USB port so that the ESP on this board can act as an input to my computer. But to add to that, well, I have DJ lights. So this S3 can now talk to the DJ lights for me. And then I have my tower light, and I want to demonstrate how that gets used. And I can combine that with a Zigbee button during my demonstration, and an old cell phone as well. And that's what the MOSFETs are for. So the MOSFETs can directly control one of my tower lights that I can set up on a demonstration platform while presenting. Because the idea of the presentation is to talk about my experience throughout life, but also how I use technology to interact with things and how I look for solutions to problems. And I can talk about the gloves aren't my original idea. Universities have done it for sign language to speech modulation. I know it's been used for music creation. There's all sorts of ways that it can be used. And the talk is specific to what I'm currently studying in school, which is child and youth care. And that's where my lived experiences and my own experiences of life come into play. And I can kind of go through things over the years of what I've learned and what I've experienced, and then my current career path and what I see for myself and the work that I currently do with the inventory project. But like I said, rather than sitting there with a clicker for a PowerPoint, I want something interactive. So like one of the DJ lights I have, it has full motion. Well, I can, with pre-programmed gestures for the hand controls, I can make it look like the thing is interacting with me like a silly robot, and that it has a personality. I'm like, hey, don't look at me, and make it turn away from me. But the moment I turn away from it, I can change my hand position to tell it, oh, hey, you can turn and face me again, and then turn back and make it act like it's not, pretending it's not looking at me, but it is looking at me, as a way of maybe garnering a bit of a laugh from the audience. But in reality, it's partially programmed and partially reliant on me doing things with my hands to trigger routines. So I would run, I'm going to bring a mini PC and connect to it a Zigbee gateway, my own Wi-Fi modem, and then on the PC I can run Proxmox with Home Assistant, Node-RED, and MQTT, and then with an old cell phone, one of the things I use my tower light for is to act as a doorbell, because I'm partially deaf and I'm often in my workshop, so I wouldn't hear the doorbell. So I can demonstrate with a Zigbee button, oh, hey, I have a doorbell, and when somebody comes to my house, or I could hand it to an audience member and say, hey, you're coming to my place, there's a doorbell on my front door, do you mind activating it? They push the button, the light turns on the tower light, and then the spare cell phone I'll use will start ringing. And I'm like, this is how I know my doorbell's gone off. And it adds that element of involving the audience while showing how I'm using technology for things. And hopefully it'll make it more enjoyable. This is true. Although the type of audience that would be in attendance it is very likely they'll be more willing to play along and enjoy that element. So it helps that I do know the type of people that would be in attendance to this type of presentation. But because it's essentially in June, I'm like, I want to work on this right away and be able to order circuit boards. Yeah, hopefully I hear back soon if they'll accept my presentation or not. So we'll see. But this is essentially done. I'll just have to remake that part. The reason I'm not doing it now is because John's about to start, so watch that and see y'all over there. As well as I have to rebuild my KiCad libraries anyways. So like, I know that part isn't there. That part needs to be remade. I think those parts exist, but might need to be remade. Yeah. What else? Yeah, some of these parts need to get remade into the library. The buttons definitely do. I know the SP does. The 5-volt regulator, this 3-volt regulator will, so I'll have to rebuild my KiCad libraries before I actually turn this into a circuit board. I might do a stream creating the circuit for the next one, and then kind of stop, rebuild the library so all the circuits can be up to date, and then I'll restream making the actual circuit boards once all the parts are ready to actually transfer to a circuit board. Just to kind of keep people in the loop. But I will let people go and give people a few minutes to grab their coffees and see people over in the super house.